In this tutorial, I will explain support vector machine theory and implementation in Python programming. Support vector machines are known to be one of the most robust and efficient prediction algorithms. SVM algorithm was developed on the framework of statistical learning theory proposed by Vladimir Vapnik. SVM training algorithm builds a model that assigns new samples to their appropriate category non-probabilistically. For binary classification, SVM finds the optimal hyperplane that best separates data points of different classes. A hyperplane is a decision boundary that separates data points of one class from those of another class. For example, in a two-dimensional space, a hyperplane is a line. Optimal hyperplane maximizes the width of gap between the two categories. Data points that are processed to the decision boundary are known as support vectors. Support vectors are critical for determining the position of the decision hyperplane. Decision boundaries are determined based on maximum margins. Margins are of two types, hard margin and soft margin. Hard margin tries to find perfect Dixon boundaries with no error on training data, which makes classifiers too sensitive for noisy or data with outliers. But real-world perfect Dixon boundaries do not exist, and perfect separation is not always feasible. In this case, soft margin allows some violation or misclassification to balance between large margin and classification errors controlled by slack variable, also known as regularization parameter or the cost parameter. A large C value indicates hard margin or a preference for accurate classification of training data, whereas a smaller C value sets the SVM for soft margins and allows misclassifications on the training data. In real-world situations, the data often is not linearly separable. To handle such a non-linear data, SVM maps the data into higher dimensional space using kernel function known as kernel trait. The idea is that in a linear decision boundary can be found in higher dimensional space if it is not possible in lower dimensions as illustrated in figure. The Gaussian or RDF kernel is a widely used function due to its capability to handle nonlinear data. Now I will illustrate stepwise Python implementation of SVM classification using publicly blessed Kansas, Wisconsin data available through scikit-learn Python package. We will first import required Python packages including scikit-learn. We start with loading data sets and prepare data for binary classification. We will also split the data in 70% of training and 30% testing sets for validation. Data is now loaded on Python. We can now create a classifier pipeline in Python using scikit-learn package. This pipeline includes standard scalar function which implements normalization processing method used in machine learning to standardize the features of a dataset, and SVC scikit-learn function to create SVM classifier. This pipeline now can be used for training SVM and make prediction on test data. We will also create here the classification report and confusion matrix. Thanks for watching.